All right, advanced math A, here we go. We got lesson 6.3.3, system solutions and graphs. So we're going to go a little bit farther into the elimination method and see some of the harder problems, but we're also going to look at what happens when we have no solution or we have infinite solutions when we're doing this type of process. We've seen it really earlier on in the unit, but now we're going to see what no solution and infinite solutions looks like when we're solving algebraically. We already saw when we were graphing it what happens. Now we're going to look at it algebraically. All right, so propose a way to combine these equations so that you will eventually have one equation with only one variable. Okay, so we're going to use the elimination method, but I only want one single variable after I've eliminated, right? So one of the variables has to go away. So let's look at our x's. 4x and 9x. There's no real easy way to get rid of it there. So let's move on. 3y and negative 4y. Now, this is not bad because one's positive, one's negative, but they're not eliminating. And I can't just multiply the 3y, the smaller one, by some number so that I can get, I mean, technically I could multiply by 4/3. Okay, so I can't multiply by an integer value. So in these situations, what I would usually suggest that you do is multiply both of the equations by different numbers. Here's what I mean. Let's say I want to get rid of the y's. Okay, so I see that I have 3y, and over here I've got negative 4y. So what number could I make those into easiest so that they, they could eliminate? Well, if I multiplied this one down here by 4, that would give me 12y. And if I multiplied this one by 3, that'd give me negative 12y. So we sometimes need to multiply both of the equations. So I'm going to take this equation here and multiply it by, I said 4, because now I'm going to get 12y right there. I'm going to take both of this sides of the equations over here, multiply it by 3, and then I'd have negative 12y right there. So let's rewrite these equations. So 4 times 4x is 16x. So we're using our multiplication property of equality, which says I can multiply the same number to both sides of the equation. So 4 times 4x, 16x, 4 times 3y, 12y, and 4 times 10, 40. Now I'm going to do the same thing over here, except multiplying by 3. 3 times 9x is 27x. 3 times negative 4y is negative 12y. And then 3 times 1, of course, is 3. All right, so the y's are eliminating, which is what I want to see. So here I've got, what's that, 43x's left over? That's a lot. So I've got 43x's, and on this side I've got 43. Okay, it's not so bad. So divide by 43, and I get x is equal to 1. Okay, so we just multiplied both the equations in order to get something that would eliminate. So let's just plug it into this first one right here. So I would do 4 times 1 plus 3y equals 10. So this is 4 plus 3y equals 10. Subtract 4 from both sides. 3y is equal to 6. Divide by 3, and y is equal to 2. Now we're going to double check to see if my solution works for the second equation. So I'm going to do 9 times 1 minus 4 times 2 and see if that equals 1. So I got 9 minus 8 equals 1. That works. So now I get 1, 2 as my answer. So sometimes you're going to have to multiply both of the equations. Next one. The art club at school is painting a mural using their school colors. Blue paint comes in a 5-ounce container, costing $2 per container. The containers of silver paint hold 2 ounces and cost $3 per container. The art club spent $56 and bought a total of 74 ounces of paint. 2 totals there. The money they spent and the ounces. Okay, so how many containers of each color did they buy? So we're looking for the containers of color. So let's let x equal what's the first one? Blue. So that's the number of blue containers. All right, we're going to let Y be the other color. What was that, silver? Silver, yep. So that's going to be the number of silver paint containers. All right, so we've got two totals here that we can make equations from. They spent $56. Now, the blue containers are $2 per container. So my first equation, based off of cost, is going to say 2 times X, because $2 for each blue. And then the silver is $3 for that, so plus 3Y equals $56. So $2 times the blue, that's all that they spent on blue, plus $3 times Y, that's all they spent on silver, equals a total of $56. Okay, the other one is going to keep track of the ounces. So my total for this one's 74. Now the blue ones came in 5-ounce containers. So I'm going to do 5 times X. So this is the ounces of blue paint. And then the silver is only 2 ounces, so plus 2Y. So this is all the ounces of silver paint, equals a total of 74 ounces of paint. All right, so these are ounces of blue, ounces of Y, total silver, total ounces 74, and this is cost. Okay, so looking at this one, I can get rid of the X's or I can get rid of the Y's. It really doesn't matter. Usually what I do is I just look for the smallest numbers. 2 and 5 are bigger numbers, so I would probably just multiply by 3 and 2. So I'd do these two equations here. Now they're both positive, that's a problem. We're going to have to make one of them negative for the Y's to cancel. So let's multiply all of this by negative 2. So that's going to give me negative 6Y. Then over here, let's multiply all of these by positive 3. And that'll give me positive 6Y. And then my Y's are going to cancel out. All right, so let's multiply this all out. I get negative 4X minus 6Y equals negative 112. The other equation, I get 15X plus 6Y. And 3 times 74, I'm going to have to think today. 3, 12, 21, 22. All right, so let's combine these sides. Over here, negative 4X and positive 15X gives me a total of 11 X's. The Y's cancel each other. 222 minus 112, I think that's 110. So divide by 11, this is working out. X is 10. All right, so it looks like 10 canisters of the blue paint. And now we need to find out how much for the other one. So let's just plug it into this equation here. Remember, we always use our starting equations because we might have made mistakes somewhere else. All right, so we're going to do 2 times 10 plus 3 times Y equals 56. So this is 20 plus 3Y equals 56. I'm going to subtract 20 and get 3Y is equal to 36. Divide by 3, and Y is going to be equal to 12. Okay, so I think there's 10 blue containers and 12 silver containers. I'm going to double check my answer because I can make mistakes. So I'm going to plug in 10 here and 12 there and see if I'm right. So 5 times 10 plus 2 times 12, does that equal 74? I think it does. So this is 50 plus 24, yep, it's 74. So 74 equals 74. Oh, it feels so good. Yes, they're equal. I know my answer. My answer is 10 containers of blue and 12 containers of silver. Delicious. All right, next, Tracy's team was given the following system by their teacher. 10x plus 4y equals negative 8, 5x plus 2y equals 10. We're going to solve it using elimination because they're going to notice something's a little bit odd on this one. Okay, so using elimination, let's see, 10x and 5, let's get rid of the x's. Let's multiply this one by negative 2. So if I multiply everything by negative 2, I get negative 10x. Okay, so my x's cancel, then minus 4y equals negative 20. All right, so the x's cancel, awesome. Oh, but the y's cancel too. So I get 0 on that side. On the other side, I get negative 28. Wait a second, all my variables are gone. What's going on here? I get 0 equals negative 28. Usually we say that's no solution, right? No solution, because 0 never equals negative 28. So what's really going on with this problem? Because Tracy's team was a little bit confused by what happened here. Well, to help us understand what actually just happened here, is we're going to write both the equations into slope-intercept form. So let's take the first equation first. First equation first, of course, yeah. Let's put it into slope-intercept form. So subtract 10x, and then divide everything by 4. So I get y equals, this can reduce, negative 5 halves x, and then minus 2. All right, that's the first equation in slope-intercept form. Let's do the second equation. 5x plus 2y equals 10. So I'm going to subtract 5x from both sides. So that gives me 2y equals negative 5x plus 10. Then I'm going to divide everything by 2. Divide everything by 2. Divide by 2. All right, so I get y equals negative 5 halves x plus 5. Now, are these two lines the same? No, they're not the same. But boom, boom, same slope. What does that mean? It means they're parallel. If they're parallel, they can't intersect, which is why we're getting no solution. So anytime you get no solution, that means that if you put them into slope-intercept form, they're going to have the same exact slope and different y-intercepts. So we notice that they have the same slope, so the lines are parallel. Now it makes sense why we got no solution. Because they're parallel lines. They can't cross each other. They can't intersect, which means there can't be a solution. So we notice that the slopes are the same. So the lines are parallel. And don't intersect. And remember, our answers are the intersection. So if they don't intersect, that means there's no solution to be had. Boom. All right, next page. All right, we're going to complete the tables for the equations and see if we can find the intersection just by completing these tables. All right, so here's my first table. Let's plug in 0 for x. I get 2y equals 8, so y is 4. Let's plug in 2. So if I plug in 2, that'd be 2y minus 10 equals 8. So that's 2y equals 18. Y is 9. If I plug in 4, I get 2y minus 20 equals 8. So that's 2y equals 28, 14. All right, so there's the first one. Part of it was done for us, yay. Next one, let's plug in some stuff here. So if I plug in negative 6 here, so let's see, if I plug in negative 6, so 5 halves times negative 6 over 1. Oops, this is getting sloppy. Minus 2. So 2 goes into 6 3 times. 3 times 5 is 15. So this is negative 15 minus 2. So that looks like negative 17 right there. Let's plug in negative 4. So 5 halves times negative 4 minus 2. So 2 goes in there twice. 2 times 5 is negative 10 minus 2. That's negative 12. Let's plug in negative 2. All right, if I plug in negative 2, 5 halves times negative 2 minus 2. So 2 goes in there once. So this is just negative 5 minus 2. That's negative 7. Do you see the pattern that's happening here? Do you see it? If you plug in 0, we get negative 2. See the pattern? Goes down, up by 5, up by 5, up by 5. Yes, the next one's going to be 3. Up by 5, 8. All right, we saw the pattern that has happened there. Now, can we see where they're intersecting? So are they intersecting here at negative 6? No. At negative 4? No. At negative 2? No. At 0? No. 2? No. 4? No. Are they getting any closer to each other? Let's see. This one is increasing by 5 here. This one's increasing by 5 all over the place. So is this one. These things are never going to catch up to each other. They're increasing at the same rate, 5 over 2. So yeah, these ones aren't going to have an intersection. So just looking at the table, I can tell by seeing their rate over here that they're not going to catch each other. They're always going to stay the same distance apart. See, from here to here, there is 6 units apart. They're still 6 units apart. They're still 6 units apart. They're still 6 units apart. Still 6. Still 6. They're always 6 units apart. So these ones are never going to catch up to each other. So let's put them in slope-intercept form. This is the only one that's not in slope-intercept form. So we'll do that one real quick. So we get 2y minus 5x equals 8. Let's add 5x to both sides. 2y equals 5x plus 8. Divide by 2, and I get y equals 5 halves x plus 4. So they have the same slope, different y-intercepts. So we know at this point that this is going to be no solution. The lines are parallel. Never going to cross each other. Now we're just going to prove that algebraically. Now the way that this is set up, I would probably end up using the substitution method because I've got one of my variables isolated. So I'm going to plug that in here for y. So I'm going to get 2 instead of y. I'm going to get 5 halves x minus 2. Minus 5x equals 8. So I just plugged in y to that one. So here 2 times 5 halves is 5x. And then 2 times negative 2 is negative 4. Minus 5x equals 8. The x's, when I combine them, they eliminate each other. And I get negative 4 equals 8. No solution. So we saw on the chart it was going to be no solution because they weren't getting any closer to each other. We saw looking at their slopes, stupid lights are going off on me. We saw looking at the slope intercept equations that they both had a slope of 5 halves, so they're parallel, no solution. And here we see algebraically that we're getting no solution. Last one. All right, so looking at this one. If you plug in 0 for x, you get negative 2, I believe. These all look like a difference of 5. Let's just fill that in. So this would be 3, and then the next one would end up being 8. All right, let's look at this one over here. If I plug in, let's just plug it in 0 first. So that's going to be negative 2. Oh, they're the same there. They must be intersecting. Let's plug in negative 2. So if I plug in negative 2, 5 halves times negative 2 minus 2. So this ends up being negative 5 minus 2. That's negative 7. So I plugged in negative 2 and I got negative 7. Wait a second. They're the same here. And they're the same here. Let's plug in positive 2. If I plug in positive 2, so 5 over 2 times 2 minus 2. So 5 over 2 times 2 is 5 minus 2, that's 3. Wait a second. They're the same again. You know what? They're the same because they're the same line. They are the exact same line. They're the same all the time. They're always intersecting each other. Doesn't look like it right now, but those are the exact same line. Let's prove it by putting this into slope-intercept form. So I'm going to take 10x minus 4y equals 8. I'm going to subtract 10x. I get negative 4y equals negative 10x plus 8, and divide everything by negative 4. So I get y equals 10 over 4 would be 5 over 2. And then 8 divided by negative 4 is negative 2. Yep, look at that. They're the exact same line. Didn't look like it, but they are, now that we've put them into slope-intercept form. So this one is having infinite solutions. Because they're always intersecting. So what do you notice? They are the same line. All right, really quickly, we're going to solve this using substitution. We're going to plug this into y right here. So we're going to do 10x minus 4, and then we're going to plug in 5 halves x minus 2 equals 8. So I'm going to distribute the 4. 2 goes into 4 twice, times 5. So that's going to be negative 10x. And then negative 4 times negative 2 is positive 8 equals 8. The 10x and the negative 10x eliminate each other, and I get 8 equals 8. And those are infinite solutions. And the reason is we can see here and we can see here that they're the exact same line. That's why we're getting infinite solutions. All right, my people, that's all I got. You guys have a good day. See you later. Bye-bye. Math hard.